This is the second half, or I should say the last third. And after the amount of work, you'll probably say, "Oh, it's the, it's the second 2/3." But this is part 2 of this particular problem, where we have a movable rod, and as it cycles through its motions, the x kind of extends out and the y decreases, and then it reverses course. In parts A and B, we found the time of one complete cycle of the rod, so we found its period. And in part B, we found the lowest point that y reaches. In essence, we found the maximum travel of the entire rod. In part C, it's asking us to find the speed of the y-axis endpoint when the x-axis endpoint is at 1/4, 0. All right, and so we've talked about it. X max, the maximum value that x can travel, is 1/2, and so this is about halfway through. All right, so let's look at our triangle here. This is the triangle that I'm speaking of, and this has kind of been guiding our thoughts the whole process. And so part C, we're going to recreate that. So for part C, we've got our triangle here that's served us so well in the past, so we'll continue to use it. It's 1 meter long is the rod. We have 0, y is the y coordinate. We have x, 0 is the x coordinate of the ends. And then we found out that this is a y value and this is an x value. Okay, now let's just throw everything out there that we know. All right, we know that x of t is equal to 1/2 sine of pi over 6t. This was given to us in the problem. We know that y squared plus x squared is equal to 1, Pythagorean's theorem. Okay. And so through this, I'm really hoping we can somehow get this y speed out. So let's find it. First, the very next thing I'm going to do is I'm going to kind of work on this problem here. I'm going to find some kind of a value for y. And so if we take and move over the x squared, we have y is the square root of 1 minus x squared. Okay, that's good, because that might come in handy later. The very next thing I'm going to do is, since this is the this particular equation holds my y's, I'm going to take the derivative of that equation with respect to t. So y squared plus x squared is equal to 1. Now when I do that, I get 2y dy dt. I'm using dy's dt's because I'm afraid if I put y prime, you'll think it's with respect to x, and it's not. So we have 2y dy dt plus 2x dx dt. This is your chain rule. Okay, so we're using the sum rule for derivatives, and we're using the chain rule. It's the derivative of the outside, which is 2y, times the derivative of what's inside, which is dy dt, equals the derivative of the outside, which is 2x, times the derivative of what's inside, which is dx dt, and then equals 0. Solving this, let's subtract 2x dx dt from both sides. And when we do that, we get 2y dy dt is equal to negative 2x dx dt. And from here, we'll go ahead and divide by 2y from both sides. And when we do that, we get dy dt, or the speed at which y changes, the endpoint of y, is equal to negative x over y dx dt. And now you'll notice that our answer depends on the position that the rod is in according to its y-axis. Well, I kind of had a foreshadowing of that up here when I said let's solve for y. And so I'm going to go ahead and stick that y right down in here into that problem. So when I do that, and I'm gonna kind of work back over here to give myself a little bit more room. Y is equal to the square root of 1 minus x squared. That means that dy dt is equal to negative x divided by the square root of 1 minus x squared dx dt. Now the beautiful thing about this is it only depends on x. So we only need that 1/4. If we didn't, we'd have to find out when x is 1/4, what is y? Okay, so we had that problem where we had, and we didn't put that down, but x is equal to 1/4 in this instance. And it's possible to do it the other way. It's just different. And so I thought I'd just kind of save us some time. All right, now we have this new thing in here though, dx dt. We don't have that. It never gave us the speed at which x was moving. And so we have to find that. So let's cruise on down here and give ourselves some space. And I'm going to kind of bring it over to the right side here and say, part 1, we have x of t is equal to 1/2 the sine of pi over 6t. Okay. The derivative with respect to t, so dx dt is equal to 1/2. The derivative of the outer thing is the derivative of sine, which is cosine. The derivative of the inner thing, so we have cosine pi over 6t times the derivative of what's inside, which is pi over 6. Okay, so we'll go ahead and clean this up a bit. So that dx dt is equal to, now if we just combine this, the 1/2 and the pi over 6, we get pi over 12 cosine pi over 6t. Now here's another problem. The speed at which x is changing is dependent upon the time or where it is in its cycle. Okay, it's not a very easy thing to see as far as that, but let's find. Now that we have that, now we know that we must have t, so we have to solve for t. Okay, so let's work again. Part 2, kind of this aside from our main instance here, is we have to solve for t. What does t equal? Okay, well, let's analyze it. We have x of t is equal to 1/2 sine of pi over 6t. Well, x, in our case here, x is 1/4. So the position is 1/4. 1/4 is equal to 1/2 sine pi over 6t. If I multiply both sides by 2, then the 2 and the 1/2 cancel, and I'm left with 1/2 is equal to sine of pi over 6t. And now you have to ask yourself, when is sine equal to 1/2? And if you remember your trig, it's at either 30 degrees or pi over 6. So pi over 6 then is equal to pi over 6t. Where sine is pi over, where sine is 1/2, the angle inside must be pi over 6, but the angle inside is also pi over 6t. If you divide both sides by pi over 6, or you can just inspect it, t is equal to 1. So 1 second. So we're going to take that and we're going to put that back into here, which means that we have, and let me bring this over here. So we have dx dt dx, the other x, is equal to pi over 12 cosine. Now t is 1, so it's just pi over 6. Now the cosine of pi over 6, in case you don't remember, is square root of 3 over 2. And so we have pi times the square root of 3 over 12 times 2, which is 24. Okay. And actually, I'm going to write that out so that you can see it. Let me erase that and write that out. So from the top, or from the beginning, we had pi over 12. Cosine of pi over 6 is simply the square root of 3 over 2. And that gives us our square root of 3 pi over 24. All of that was an aside, because all we needed from that was dx dt, and that's what we got. Okay, so let's go ahead and work back on our original problem here. dy dt is equal to -1/4 divided by the square root of 1 minus 1/4 squared times square root of 3 pi over 24. Okay? So simplify this. dy dt is equal to negative 1/4 divided by the square root 1 minus, now 1/4 squared is 1/16. 1 minus 1/16 is just 15/16. And we have the square root of 3 pi over 24. So simplifying yet again, dy dt is equal to negative 1/4 divided by the square root of 15 over 4. And this is square root of 3 pi over 24. Pi is outside of the root, by the way. That's all we've been doing is just kind of trying to get things simplified down here. Now, if you take and invert and multiply like you're supposed to with fractions, then we have dy dt is equal to negative 1/4 times 4 over 15, root 15. And this is multiplied by the square root of 3 pi over 24. 4's cancel, and so I get dy dt is equal to negative square root of 3 pi over root 15 times 24. Most books are not going to let you keep it this way. They're going to say, okay, rationalize the denominator. So let's go ahead. We're going to multiply top and bottom by root 15. That'll rationalize the denominator, get rid of that root. So we have dy dt is equal to negative the square root of 45. If you don't recall, remember when we multiply roots together when they have the same indices, we multiply the things underneath. And so we get square root of 45. And pi is outside, and then we get 15 times 24. I'm not going to do that yet because I see something here. I can bring a 9 out of the square roots. This is 45 is 9 times 5. I can bring a 3 out then. So we have square root of 9 is 3, roots of 5 pi all over 15 times 24. Now I take and cancel out the 3. This becomes a 5, and dy t is equal to the negative of the square root of 5 pi all over 120. So now I had to go through it, and there were a couple different things that I had to do. I started working. Okay, so if we start back kind of towards the beginning, I drew myself a picture, wrote down everything that I needed to know, or at least what I thought I needed to know up to that point. After that, I tried to find dy dt. That gave me a hint as to what else I needed. I found out when I did that I needed x. Oh, I have x. Okay, that's good. But now I needed that dx dt, and that was hard. I had to go out and go searching for that one. So I took the derivative of the function of x with respect to t. That gave me my rate, but then we had a problem where I still depended on time. Excuse me. Depended on time. So I had to go back and find that, plug that back into my rate of x changing to get a final dx dt. After that, I just plugged in the numbers and ran through the arithmetic and simplifications. Okay, so that after that, I mean, it's all algebra from there on out. So what does it say? Well, it says that the speed at which this is changing, where's my white? The speed at which it's changing is square root of 5 pi over 120. The sign comes in that it says basically if x is increasing, y is decreasing. And if x is decreasing, y is increasing. And so it sets up a negative relationship between the two. When one moves, when one moves in the positive direction, the other one moves in the negative, and that sort of thing. So just keep plugging away at these. They're tough, but it's worth it.